So now that we've covered the mechanisms that are used to implement this embarrassingly parallel program for looking at the various phrases, looking for the various phrases in the works of Shakespeare, let's go ahead and evaluate the pros and cons of the approach that we've done. And of course, the pros are mostly relative to using just classic Java object-oriented features in isolation, and we'll see that there's a bunch of pros. But the cons are going to be used to motivate the need for the more advanced Java functional parallelism frameworks. So you could actually go, if you want to see kind of the baseline version, I have another implementation of this program that uses only Java object-oriented features. Nary a lambda expression or method reference or functional interfaces to be found anywhere. It doesn't quite implement exactly the same logic, but it does the same concept of embarrassingly parallel processing. And the new version here is much better than the old version. And here's some reasons why it's better. And the reason why it's better is that the older version, the original object-oriented version, has a lot more syntax, and it also uses traditional for loops. So for example, here's a good example of an index-based for loop. And index-based for loops are notorious for their off by one error potential, because it's all too easy to forget to start at 0 or to do it for I less than or equal to the ending condition, and you get yourself off by 1, and just a pain. So that's one of the problems. The other problem is you end up locking yourself into the so-called accumulator anti-pattern, which we've talked about in the past as well. The downside with using object-oriented features is also the fact that there's a lot of syntax involved. So if you want to do anonymous inner classes, which is what we're doing here, you end up having to write a lot more code. Not the end of the world, but it's just more tedious and error-prone, and probably contributes to more cases of carpal tunnel syndrome than the alternative. So as a consequence, because of this, the object-oriented version of this is just more tedious and error-prone to program. Doesn't make it bad, it just means it's not as good as it could be if we used more modern features, which is probably no surprise. In contrast, the functional programming implementation is more concise, more extensible, and more robust. And that's because it's using a lot of these declarative Java features like for each and functional interfaces and method references and lambda expressions to make it not only more expressive in order to do things, but also just less error prone and more concise and easier to understand once you know how to read all the syntax. As an example, the for each method we're looking at here avoids these off by one fence post errors that you can run into if you use index-based for loops in Java. Likewise, passing method references or lambda expressions via functional interfaces simplifies behavior parameterization. It's just cleaner, easier to make changes, easier to pass in something new without having to do a lot of surgery to the code that you've already written. However, not everything is rainbows and unicorns, as I like to say. So there's still some accidental complexity lurking in this initial cut at doing a Java functional programming approach to parallel processing. And once again, the problems here really stem from the so-called accidental complexities of using these low-level Java concurrency mechanisms like threads. So for example, one obvious problem here is you have to remember to start your threads. And I can't tell you the number of times I've worked with people in classes, not this class because we don't use threads, but in other classes that do use threads, and people will write their program and they try to run it and it doesn't do anything. They're like, what the heck? It looks correct. And what they forgot to do is they forgot to start their threads. So it's a very easy mistake to make. So you have to remember to start your threads. Likewise, if you're going to join with threads, then you have to deal with the fact that functional programming and some of the Java threading methods with their use of checked exceptions mean you have a lot of extra work to do when you write your code. And this code is just very ugly. There's a lot of extra verbosity involved here to handle exceptions, checked exceptions, when you start combining them with modern Java features. There are ways around this using something called exception laundering, which sounds like money laundering. But exception laundering is a way to abstract checked exceptions and automatically convert them into runtime or unchecked exceptions. And it's actually a pretty cool technique, but there's some pros and cons to that as well. First of all, you have to understand the concept, but there's got to be better ways to do that. And of course, there are. Another limitation with this approach that we've looked at is we have only one parallelism model supported. It uses the thread per work of Shakespeare model, and it's hard-coded. So the number of threads in the program will correspond to the number of input strings. That's probably not the end of the world. There's only basically 38 works of Shakespeare, spawning 38 threads, not going to cause most systems to come to a screeching halt. But you can imagine other scenarios where you had hundreds or thousands of inputs to deal with, like the complete works of L. Ron Hubbard, for example, or pick your favorite author that like Stephen King, that writes, probably written hundreds of articles and books over time. So then you would end up with a large number of threads, and that may not be the right model. But the point of this is, no matter whether it's the right or wrong model, when it is the wrong model, it takes a lot of work to change what we have here to a different model. And that's because the code that we wrote is insufficiently declarative. We said imperatively what we wanted it to do, and we wrote the code to correspond to that, rather than letting the system figure out what it wanted to do and us just saying what we wanted our intent to be. Now, that may or may not make a lot of sense yet, but when we get a little further along, you'll see it makes a lot of sense. Another thing to note here is that the structure of the code that we have here that runs in parallel is quite different than code we would write if we wanted to run this sequentially. So switching from sequential to parallel and vice versa would require substantial modification and revision, and would probably break things, and you'd have to do a lot more testing and other types of quality assurance. So what are we going to do about this? Well, obviously what we're going to do about this, and this is kind of the rest of the class, is we're going to solve these problems by applying more advanced features in the more modern versions of Java. So we'll be applying parallel streams, we'll be applying completable futures, we'll be applying fork join pool, we'll be applying RxJava and Project Reactor, and so on and so forth. And those things will allow us to be able to build this kind of a solution much more flexibly, much more extensively, arguably much more readably once you understand how to read the syntax and understand the semantics of these higher level frameworks. And in a sense, you can think about all these functional programming parallelism frameworks as providing some kind of a facade, in the sense of the Gang of Four facade pattern, around Java's earlier object-oriented features. So we don't lose anything, we just get new capability, but that capability still works efficiently because the underlying infrastructure, like the fork join pool and the other mechanisms, are done in a very clever and optimized way. The other thing you'll note when we get there, especially for the parallel streams code, is that the structure of the parallel code is nearly identical to the sequential code. So going from sequential to parallel requires very little modifications, and that's the beauty of doing things in a functional way. So that wraps up our discussion of this example. From now on, we're going to be focusing on the cooler features of Java. This was just a way to bridge between the old school way in an object-oriented world and the modern way using functions and functional features. And now we're going to start expanding and building upon that.